No, I'll get in there. Did it make it through? No, not yet. All right, here we go. Important geometry vocab. So before we start digging into more into area, and we're going to get into volume tomorrow, three-dimensional figures, I got to cover some important vocab before I introduce you to that, because you'll get nightmares if I don't. So I want you guys to sleep. I want you to have nightmares. Let's go and write the word parallel. Two lines that extend infinitely and never intersect. Ready, Garcia? Two lines that extend infinitely and never intersect. You give an example.
Just put two lines straight.
Well, every line is straight, right? But two lines that never intersect look like this. They never touch. So going infinitely without ever touching. There's a symbol. Usually put little arrows on both, like this. That's communicating the lines are parallel. Okay? Now let's just say you got some points on the line, like A, B, or C, D. If I want to say the two lines are parallel, look at the parallel symbol. Say line AB, the line symbol, is parallel. It's like these double bars. That's the symbol for parallel. On a picture, the arrows are a symbol for parallel. If you want to say a mathematical statement like this line is parallel to this line, it's that double bar there. So line AB is parallel, like a double bar, to line CD. Okay? So parallel. Lines going on forever without ever touching. Now that's related to some of the shapes I threw at you, Chin. So I got the floor right now. The gizmo's away. If I throw a parallelogram at you, look at the parallelogram. On your formula table I threw at you last week, a parallelogram by definition is a four-sided figure where opposite sides are parallel. Look at the arrows here. And I'll put double arrows here. So opposite sides of a quadrilateral that are parallel, you have a parallelogram. Notice. But what would a quadrilateral, a four-sided figure look like if you only had one pair of opposite sides parallel? That would be a trapezoid. That's another figure that's on your formula table. Look at this four-sided figure. Only these two sides are parallel. These two sides are not. Only these two are. So this would be a trapezoid. Right, they would never touch. If you were to extend them, they would never touch. Exactly. So this is a trapezoid. This is a parallelogram. The only difference is that a parallelogram has opposite sides parallel both. Trapezoid only has one pair. So far, so good. Now on a trapezoid, the two sides that are parallel are your bases. So go ahead and put arrows on both sides that are parallel. These are your bases. This is the only shape that has two bases out of all the shapes I'm throwing at you to find area on your table. The two sides that are parallel are your bases of your trapezoid. Okay? Take note of that. So that's the first important vocabulary word, parallel. You see that come about on these types of shapes, a parallelogram and a trapezoid. Next important vocab is the word perpendicular. Perpendicular. So let me draw two lines that intersect to form a 90-degree angle. Check it out. So here's line AB, line CD, look at this, and they intersect to form a 90-degree angle. Okay, I'm going to put a little box there. That's the universal symbol for 90 degrees. We went over that last week. And look at the statement I'm going to make. Line AB, not parallel with CD, it's perpendicular. Look at the symbol for perpendicular. It's like an upside down T. Line AB is perpendicular to line CD. So the perpendicular symbol is this upside down T looking good one. Sorry. It is. So parallel versus perpendicular. Get them right in your mind. Two never intersect. Perpendicular means they intersect to form a 90-degree angle. Pretty straightforward, I trust. Pretty clear, I trust. Okay, last word of the day. And I talked about it last week, but only in passing. Last word is height or altitude. You'll see either one on whatever, depending on what geometry textbook you have. The height or altitude. The perpendicular distance from the base of a triangle, parallelogram, or trapezoid to the opposite vertex. The perpendicular distance from the base of a triangle, parallelogram, or trapezoid to the opposite vertex. So on a triangle, what does perpendicular mean again? Right, it's two lines forming 90 degrees. So, okay, so if this is your base here of your triangle, this side, then the distance that's perpendicular, look at it, 90 degrees, perpendicular from the base to the opposite vertex. Here's your vertex. That's your height. So that's for a triangle. Okay, what about a parallelogram? What's the height of a parallelogram? Well, it's the same thing. It's the perpendicular distance from the base to the opposite vertex. Let me show you what I'm talking about. Let me draw a parallelogram. Do it with me. Again, the arrows indicate parallel. Watch this. This is my base now. Look at this. Perpendicular, look at 90 degrees. The height now is there. And the opposite vertex is right there. Notice the similarity. The height is always the perpendicular, 90 degrees, distance from the base to the opposite vertex. Now let me draw the situation with the trapezoid now. Trapezoid type. Trapezoid. Two sides are parallel. Perpendicular. Base here, base there. So on a trapezoid, there's two bases. And the height is the perpendicular distance. Yeah. Opposite vertex. Here's your opposite vertex, right there. Notice how the height means the same thing for all three different kinds of shapes. It's the perpendicular distance from the base to the opposite vertex. The only thing you got to remember on the trapezoid, you have two bases. The two sides are parallel. And that'll come into play when you use your formula. Okay? We'll play this video that's put on by high schoolers. This group is called the standard deviance.
Oh, wow.
Yeah. Deviant means like you're abnormal, but it's like a play on mathematical words because when you get into statistics, it's called standard deviation. So they call themselves standard deviants. I get it. Never mind.
Yeah.
Okay, here we go.